So this is the 2002 question 22. It's a gas laws question with a little bit about pressure in it as well. So a technician designs the apparatus shown in the diagram to investigate the relationship between temperature and pressure, much like the field experiment that we set up yesterday. Constant volume. Remember, when you're looking at pressure and temperature, you must have a constant volume. Similarly, if you're looking at pressure and volume, you must have a constant temperature. So the pressure of nitrogen is 109 kilopascals when its temperature is 15 degrees. So that's P1 and T1. Temperature of nitrogen rises to 45 degrees Celsius, so that's T2. Calculate the new pressure of the nitrogen in the flask. So that's what we're looking to do first of all. So remember that this must be in Kelvin, the temperature, because it doesn't work otherwise. So P1 over T1 is equal to P2 over T2. That's the second of our gas laws that we've looked at thus far. The first pressure will be 109 kilopascals. The temperature, remember, converted into Kelvin, will be 288. That will be equal to P2 over 318. P2 will come out as being 120.35 kilopascals, which we'll call 120 kilopascals. Okay, so 2 marks for that. Second part, part B. Explain in terms of the movement of gas molecules what happens to the pressure of the nitrogen as its temperature is increased. Now, this isn't necessarily something that I have shown you how to do, but I did hear some of you talking about kinetic energy and things like that whilst you were doing it, so that's good. You're obviously doing some of this stuff in chemistry, but for the benefit of those that aren't, I will go over how to answer this type of question, but we will come back to this at the very end of gas laws. This is the last thing I'll do with you. For each of these questions are the same year upon year. Sometimes it might not be pressure and temperature, sometimes it might be pressure and volume. But you know, it can be for any of the gas laws to explain it in terms of particle movement. So I would always use the 3 F's for this. So 3 F's are force, faster, frequency. So what that means for this type of answer is that the particles are moving faster for your first one there, so they've got more kinetic energy. They are colliding more frequently, both with each other and with the walls of the container, and they are also hitting the walls of the container with more force. That's where those 3 F's come from. So as temperature increases, that should be the kind of answer I'd be looking for you to write. As the temperature increases, molecules have more kinetic energy. So it's all about kinetic energy. As you heat something up, you provide more kinetic energy to these particles, and that changes the pressure in turn. The reason why the pressure changes is because the particles are colliding more frequently with greater force, and they are moving faster as well. So therefore they travel faster, hit the container walls more frequently and with greater force. And with greater force, increasing the pressure. That's what's basically going on inside a gas to increase the pressure. So we're really looking at these 3 F's: force, faster, frequency, or faster, frequent, forceful, depending on which way you want to kind of remember it. So that's how we tackle these types of questions. But don't worry too much about that. We will come back to that again later. Okay, next part of the question. that's useful. Okay, calculate the force, given a graph there. Calculate the force exerted by the nitrogen on the piston when the reading on the pressure gauge is 1.75 times 10 to the power of 5 Pascal. Now on the previous page there you get given an area. So for C part 1 you're looking at this equation. Rearrange that for F. You get F equals PA. Force equals pressure times area. So you end up with 1.75 times 10 to the power of 5 multiplied by the area, which is given on the previous page, 4 times 10 to the negative 6. You get 0.7 newtons. Part 2. What is the length of the spring in the safety valve when the pressure of the nitrogen is 1.75 times 10 to the power of 5 pascals? So what you're doing there is looking at the graph and following 0.7 newtons down and getting a length of the spring of 35 millimeters. So it's just simple data interpretation. Last part. The technician decides to redesign the apparatus so that the bulb of the thermometer is placed inside the flask. Give one reason why this improves the design of the apparatus. It's because the thermometer is now measuring the temperature of the nitrogen directly. Guys, don't pack away please, I'm still working here. It's measuring the temperature of the nitrogen. We'll just put an N for that. Temperature of nitrogen directly, rather than assuming that the water and the nitrogen are at the same temperature. So it's actually inside the container rather than outside of it.